Alright, this question says you have a satellite that orbits 100 kilometers above the surface of the Earth, and it gives you the radius of the Earth as 6,378 kilometers, and it asks how fast it's moving, and it gives you the mass of the Earth. So let's go ahead and draw what we have going on here. You have the Earth, and you have a satellite that is in orbit around the Earth. So I'll say that's my satellite. This right here is the center of the Earth. Now, why is that important? That's important because you have this distance right here as 6,378, and you have this distance right here as being 100. Now, realize that whenever you're doing the gravitational force calculations, the R value that's represented as the distance between the objects does not represent this 100 kilometers, but it's from the center of one object to the center of another. Now, the center of a satellite, the satellite's going to be at most 2 or 3 meters big, so because of that, it's really irrelevant. But this right here, this 6,378, is actually very, very relevant. So the radius for our calculations is actually going to be 6,478 kilometers, which then I can convert to meters as 6478000 meters. So it's really important that we take into account the radius of the Earth when we're looking at this calculation. So it says we want to know how fast the satellite is moving. We know that we were going to have to use our tangential velocity formula relationship, VT squared GM1 over R. Okay, that's the form that we originally had, so we can say, okay, the tangential velocity is going to equal the square root of g. Remember, g is the universal gravitational constant. You can find it on the star formula chart, and it is 6.67 times 10 to the minus 11th. You also have m1 that gives you the mass of the Earth, which it told us was 5.98 times 10 to the 24th. That was in kilograms. So now we can just plug in. We say 6.67 times 10 to the minus 11th times 5.98 times 10 to the 24th, and all of that is divided by our radius value, which is 6,478,000 meters. Whenever we do this, we realize that the square root, everything is under the square root, so we have to do all of our math first. 6.67 e minus 11 times 5.98 E24. Hold on, I got in the wrong mode here. 6.67 E minus 11 times 5.98 E24 divided by 6478000. So that right there gives you a pretty high number. Whenever you look at that number, you should say, well, that's a pretty big number. Do not forget to take the square root. As you'll see a little bit later, this number is actually very, very close to the speed of light, which is not relevant. It's not accurate for a satellite. So you should be able to say, got to take the square root of that, which gives me a more reasonable number of 7,846 meters per second. Now that is still a very high number, but it makes sense. You're launching a satellite on a spacecraft using rockets to place it into orbit. So you're actually moving it very, very, very quickly. Okay, so let's make sure our